Hi, today we will study about engineering of immunity. So we want to study our immune system and lymphatics and the role of vaccines and antibodies in disease prevention. So first of all, what's the role of our immune system? So our immune system is like a soldier or military system in our body, which will monitor if there's any invasion of pathogens, such as bacteria or viruses or toxins coming in. And then if we find it, attack it. And then also after this, prepare for the next invasion by memorizing and prepare. So the cells which comprises of this immune system has to know who is our enemy or our own. So that our cells have to distinguish a self from non-self. Non-self we typically call a foreign. So there are common features among different cell types in our immune system, which is the cells of immune system should recognize a self. And also it has a function to surveillance and defense and clear those who debris or after we attack those invasions. And for that, our immune cells also have to have a very good communication system among and between our cells. So that's signaling is very important. That could be direct cell-to-cell contact signaling, or the cells even signal by themselves, so that it's called autocrine, so it can maybe proliferate when necessary. Also, the cells signal from one part to the other on nearby cells, and that's called the paracrine. So we have discussed about circulation extensively because the heart disease is one of the major causes of death. Now, let's look at the other rest part, which is lymphatics. And there are lymphatic capillaries. So remember that in our circulation of blood, there's arterial, and capillary, and venous, and vein. So with this presence of blood capillary, in fact, there's an intricate intermingle of lymphatic capillaries together. The difference between lymphatic versus blood circulation is a closed system, while lymphatic is more like one-way road. So lymphatic capillary, you see, it's not a closed circuit, but it's an open in one side. So that tip of the lymphatic vessels, if you look at closer, there's a lymphatic endothelial cells, and these part of lymphatic endothelial cell has a flap-like structure that's linked to collagen filament to anchored to connective tissue, so that it's more like passive opening at the tip, which sucks tissue fluid into this lymphatic vessel. So how does lymphatic vessels connect to our major blood circulation, which is depicted here? We already know that the blood circulation. So from pulmonary or system capillaries, we have tissue fluid drainage into lymphatic capillaries, which is like this structure. And it has a valve system because the major part of lymphatic vessels, it doesn't have like pressure inducing organ like heart. So it's more like passive. So like a vein, it has a valve system so that it prevents a backflow. And also you can notice that there is a lymph node from here and there, which is like in the drainage system, there exists our immune military system, which observes the local things happening, what is coming into our drainages. So that's what lymph node, and I will discuss more about this structure later. And eventually what happens is this lymphatic vessel ends up connected to our main vein system, so that it, in fact, it's mixed with our major blood circulation. So that's actually the liquid portion of lymphatic vessels connected to the blood, and the blood contains what's called blood plasma. So when you centrifuge the blood contains many cells and also the liquid portion, and that liquid portion is called plasma, and you centrifuge, then the RBCs get down, and on top of that, a very thin white blood cells come up. And with the platelet, the color looks, because of the scattering, that's why we call it white blood. And typically about the rest is called the plasma. And plasma is that liquid component of blood, while blood cells are suspended. So here's an example of from wartime photo that a soldier was injured from a trauma from a bomb shell. And he lost a lot of blood, so he needs a transfusion. So this shows the transfusion of blood plasma. This one usually keeps it in a frozen way, and that plasma is important for blood transfusion, so that's plasma. And the plasma contains very important, mostly water, but it contains proteins such as albumin and also glucose, and many electrolytes, and also plasma contains a very important clotting factors, which is important to protect our cell from blood loss. But for experiment, sometimes we don't need it, so we can make plasma without clotting factors such as fibrinogen, and that we call serum. You remember from cell culture, we add this cell culture medium with a serum, which contains lots of growth factors and proteins, but that serum do not need clotting factors, so that's why serum, or we call BSA, bovine serum, like this. So I brought one movie which I made with a real-time imaging of blood vessel inside the brain. So I want to show you how this white blood cell, which is an immune cell, circulate and roll inside our blood vessel, especially in the cranial window of mouse brain. For this, I actually developed a real-time video rate to photon microscope. So that requires this resonant galvanometer to make almost 30 frames per second possible, like what we see. So here, that you see, remember the blood after suspension, I use a stain of the red blood cell and white blood, some part of portion of cell, so that we can visualize with a fluorescence microscope. So let's take a look. So these are the cells, and fast moving cells are red blood cells, and the big ones are white blood cells. You see the white blood cells sitting there, and these are red blood cells. Let me show you one more time. You notice that while red blood cells are flowing fast, white blood cells, some of white blood cells are actually on the wall of this big vessel. You see, they are like stick there, they are crawling, they are waiting. If there's a local inflammation, they will get stuck and then come out of the tissue towards moving, migrate to the place of inflammation of external pathogens. So another video I also have, this is, I invite this study video rate multiphoton microscope for tumor microenvironment. But here I want to show a lymphatic metastasis. So the tumor cells can metastasize via blood vessel, which is called hematogenous metastasis, while we also use local lymph node as to see whether metastasis happens or not. So we can observe a lymphatics by injecting a contrast agent. So it's a negative contrast, and we want to see whether how metastasis happens and can we capture it by this microscope. Let me play it. So you see, these are real time. So you see like it's moving from the pulsation of nearby arteries, and you see the, so these are lymphatic vessels, and we can find cancer cell clump we are curious whether the cancer clumps are moving. And you see these ones are like contrast agent based. And I want to move on to go here to see. So these lymphatic valves can open and cancer cell clump can come up. So we may be able to capture this moment by using microscope and at the cellular level, what's happening. So let's go back to review our immunological system. And so the key part of our lymphatics is in fact the lymph node. So lymph node looks like this. Lymph node is a small organ distributed throughout our body, and that's actively connected with our circulation because the immune cells can get into and out of circulation. So for that, single lymph node needs an artery and vein. They will have this artery, arterial, and venous. So active interaction and changes of immune cells come in and out. So also lymph node has its own lymphatic drainage of input and output. We call it as afferent lymphatic vessels and efferent lymphatic vessels. So this is a system that watches what's happening in our tissue. Is there any invasion from pathogens? So that we have a collection of densely packed B cells and T cells. These are a typical adaptive immune system cells, and macrophage, big cell-eating cells, and plasma cells, which is an antibody-producing cell. So they are gathered here, always watching what's happening in our tissue. If there's any injury, there's any pathogens or virus, bacteria gets inside our body. So we are surveilling it. And so the organs comprising our immune system can be shown here. As you can see, tonsils and adenoids, so lymphatic lymph nodes, and there are thymus, and there are spleen is a big organ which contains a lot of B cells, and also our gut is directly in contact with many foods products from outside. So we have a lot of lymphatic system, lymph node system called the Peyer's patch, and appendix. You know, appendicitis is a big inflammation can cause a problem, or we sometimes resect this appendix. And also bone marrow inside the bone is a big place for our immune system. So bone marrow and a thymus, where the T cell, T cell stands for that thymus. So T cell maturation happens in the thymus, and the spleen, where a lot of B cells are there, and lymph node throughout in our body are actually protecting and surveilling our body from external attack. So we have to understand this immune system so that we can engineer, and one of the big example is a vaccine development. So the goal of engineering immunity is, can we enhance the function of our immune system, and such as vaccine development. In our human civilization, the emergence of a mega city, a big city which has more than, let's say, millions or 10 million people gathered in a city is possible by the development of our this vaccine. Otherwise, we can have a lot of contagious diseases. Still, we're not perfect because there are many diseases, smallpox, rabies, and these diseases are, we do have a vaccine. So that allows us to gather together in a closed space, while still there are many diseases which do not have a vaccine available. I just go through one by one. Example, smallpox is a variola, other words, it's a viral disease. It can be fatal, but it's effectively eradicated by the year 1979. And rabies virus, this is a viral disease, very contagious and fatal disease, which causes a convulsion and madness. While typhoid is caused by a bacterium called Salmonella typhi, and tetanus is also caused by a bacterium, Clostridium tetani. And polio, you may heard, and the full name is a poliomyelitis, causing a muscular paralysis, which is a viral disease of the central nervous system. And measles is a viral disease causing fever and red rash. And rubella is a viral disease. So nowadays in advanced modern countries, we do give a prophylactic vaccination to our kids or newborns. And varicella is another word, chickenpox, which is caused by varicella zoster virus. So for this, we need a understand about vaccine. So what is vaccine? Vaccine is a biological agent to stimulate our body's immune system by recognizing that external attack or agent as a foreign. So we need to know who's our side and who's the opposite side. And once we identify, then we'll destroy and remembering it for future attack. So many vaccines are used to stimulate the production of, in fact, antibodies, okay, and provide immunity against a particular disease. So antibody is a very specific for particular one. So we will discuss more. And so next time we'll discuss elements of antibody structure and several antibody classes and the function of antibody to protect us from antigens. And thank you very much for your attention.